Welcome, intrepid explorers, to a brand new explainer. Today, we're embarking on a cinematic safari, venturing deep into the wild mechanics of the physical world. I want you to imagine we're stepping right out into the tall grass of your technology grade 7 exam preparation. We're going to observe, track, and hopefully master the fascinating systems that power our world. Systems that are, quite literally, hiding in plain sight. Okay, let's dive right into this.
Now, every good safari needs a map. Today, we'll navigate the complex undergrowth of linked levers and linkages, wade into the powerful currents of pneumatic and hydraulic systems, and then finish up with a quick revision short test just to keep our survival skills incredibly sharp.
Section 1. Linked levers and linkages. If you watch closely, you'll see these structures functioning all around us.
We begin our tracking with question 16. What does a linkage consist of? Just think about it for a second. What actually brings a mechanical linkage to life out there in the wild?
Well, here's the answer. A linkage, or a linked system, is fundamentally a miniature mechanical ecosystem. It consists of two or more levers connected with pivots. Now, some of these pivots are fixed to a single spot, while others are actually moving. And it's this precise connection that allows them to work together in absolute, perfect harmony.
Moving deeper into the brush, we find question 17, asking for examples across different classes of levers. And what's truly fascinating here is that these mechanical marvels are lurking right inside your own homes. A first-class lever system, well, that's your everyday scissors or pliers. A second-class linked system, think of a nutcracker crushing a tough shell, or maybe an office punch. And a linked third-class system, that would be the swift pinch of tweezers or your trusty stapler. Beautifully adapted tools right at our fingertips.
But, nature always evolves. Which brings us to question 18. What is a complex linkage, and name 3 examples? Try to envision a more evolved, multi-layered mechanical structure here. What happens when we add even more to this ecosystem?
In complex linkages is, quite simply, a system consisting of more than 2 levers. By adding just one or more extra levers, we create these magnificent, highly functional beasts. I mean, think of bri tongs flipping food over a fire, or the expanding, crisscrossing metal of a security door, even the folding mechanism of a stepladder. Those are all complex linkages in action.
Moving on to Section 2, Pneumatic and Hydraulic Systems. We're now shifting our focus to the powerful, flowing, hidden world of fluid mechanics.
Let's look at question 19. How do they transfer movement? The answer is brilliantly simple, yet incredibly powerful. They transfer movement by using pressure in cylinders. Think of them kind of like syringes and pistons that are all connected by pipes. Honestly, it's like watching energy move through a vine across the jungle canopy.
Now, we actually split this territory into 2 distinct habitats. First, question 20 asks, what does a pneumatic system use? The answer? It works with compressed air or gas. Here, we're literally harnessing the invisible.
But why does this actually work? Question 21 asks exactly that. Why can air be compressed easily? Well, it's because air molecules have a massive amount of empty space between them. It's a microscopic vastness that allows the air to be squeezed super tight.
This invisible strength definitely has a vulnerability, though. Question 22 asks, why does a pneumatic system deliver less force? The answer lies in its airy nature. Because the air compresses so easily, it actually gives way, or acts a bit spongy, when it's placed under heavy weights. It simply lacks the backbone for heavy lifting.
And that brings us to the heavier, denser apex predator of this territory. Question 23. What does a hydraulic system use? Instead of gas, a hydraulic system works with a liquid, usually water or oil.
Now, brace yourselves for question 24, because this is really the turning point of our safari. Can a liquid in a hydraulic system be compressed? Just think about the physical properties of water and oil compared to the airy space of gas.
The answer is an absolute no. Liquids cannot be compressed at all. This is a rigid, unyielding law of nature, and it has absolutely incredible mechanical implications.
Which perfectly answers question 25. Why are hydraulics stronger? Because liquid cannot compress. When you apply pressure to it, that force has nowhere to hide, delivering immense power capable of effortlessly lifting massive, heavy objects like cars. It's raw, unyielding mechanical strength.
Section 3, quick revision short test. All right, explorers, it's time for a rapid-fire survival test to secure all the knowledge we've gathered today.
Question 26 asks for the 5 steps in the design process. Now, every great invention undergoes this exact evolutionary lifestyle. Step 1, we investigate. Step 2, we design. Step 3, we make. Step 4, we evaluate. And finally, Step 5, we communicate our findings to the world.
Question 27 takes us straight to the drawing board. What is a thin, dashed line? This represents hidden detail. It essentially maps out the secret skeletons of objects, the edges tucked away beneath the surface that you just cannot see from the outside.
Next up is question 28. What does the scale of 1 to 3 mean? It means it is scaled down. It's a reduction scale used to tame massive real-world structures, meaning the real true object out in the wild is exactly 3 times larger than the tiny drawing captured on your paper.
Question 29 asks, what is a wheelbarrow's lever class? So the crucial point here is looking at the anatomy of the machine. It's a second-class lever. Why? Because the load, the heavy dirt you're carrying, sits right in the middle, perfectly balanced between the fulcrum, which is the front wheel, and the effort, which is the physical force from your hands on the handles.
And finally, we've reached the grand finale of our exam prep journey, the ultimate question. Question 30. What is the main reason why hydraulics are more powerful than pneumatics? Let's just pause. Recall the fluid mechanics we just tracked.
This brilliantly illustrates the ultimate rule. It's a head-to-head battle of physics. Hydraulics win because liquids simply cannot be compressed. Pneumatics fall short in brute strength because air and gas compress easily under pressure. Lock that comparison right into your memory.
Well, we've successfully navigated the technology grade 7 territory together, but the safari doesn't really end here. As you step away from this explainer and venture back out into your own world, I want to leave you with this. What hidden mechanical beasts, what complex linkages, what powerful hydraulic systems will you discover hiding in plain sight in your own home? Keep your eyes wide open, explorers. Until next time, keep observing and keep learning.